So this is the revisiting the scene graph as bus concept into networking heterogeneous applications using GLTF fragments project. Um, it's a bit of a mouthful, but hopefully the presentation should simplify things a little bit. So my name is Jaspreet, and in fact, this was before we wrote the paper. This was an MSc project dissertation, and I was lucky enough to have Anthony supervise the project with me. And together, we Anthony and I are big fans of kind of online experiences and Fortnite and kind of all of these things. And um, you know, one thing as we surveyed the existing, um, you know, distributed graphical applications, we saw that these kind of applications, they use application-specific messages to broadcast the state of the virtual environment to other clients on the network. And over the years, this has become a really efficient way of communicating information between clients on the network. Um, but what happens is we rarely see, two different applications or two applications that are built in different frameworks. For example, Unity, something that's built in Unity versus something that's built on the web. These applications rarely interoperate. And what we mean by interoperability between graphical applications, graphical distributed applications, should I say, is that content is never really, or assets are never really um, brought into other environments or shared between these environments. And I think one of the reasons for this is that um, uh, the messages used to communicate state between these applications um, often have a lot of um, engine specific detail in the data structures. So, Unity might describe geometry in a certain way, whereas a different engine may not use an OpenGL layout, may use a different layout to for the vertices of the geometry, for example. And so those are some of the challenges, and what has been used in the past to kind of fix this problem is um, um, ways of abstracting the scene using a scene graph. So I know I haven't really used X3D or VRML now, VRML, but my supervisor Anthony could talk for hours about it. Um, standard X3D used a common scene graph data structures. And more interestingly, the paper that we directly cite in our title, Scene Graph as Bus, uh, they use an approach called a neutral scene graph, um, where game engines could convert, or applications can convert their local representation of the scene into this kind of ubiquitous, almost you know this data structure that could be translated to and from applications. So you have these wildly diverse applications, but they all communicate using the same data structure layout, the neutral scene graph, what it actually is. And our goal was to revisit this. How could we use these latest game engines, these latest tools and technologies, and kind of um, communicate state. So we chose GLTF, um, and we tested this on three different applications. We tested in Unity, which is used to create AAA games, very highly popular engine. We used Three.js, highly popular web framework, and Python, which is a highly popular language in general. And we called it the Hyperverse protocol, the Hyperverse Transfer Protocol, should I say? So we built these applications, and we just each of these applications support sockets, with the exception of Three.js, which uses WebSockets, but we can still communicate. Um, and uh, what this means is that we can have a server which has some GLTF information or some GLTF binary information, otherwise called GLB, and it can go to the server, connect to the server, and then the server will pass this GLB message of the entire scene. Um, these messages are kind of what we talked about earlier, but um, instead of specific things to do with the actual um, application, they're more generic. So these messages carry a payload, and this payload is the GLTF information. Kind of running out of time, but these messages they either include the whole GLB file, the GLTF files, or they can include little snippets of it, or they could use translations. And if I just give you a quick demo of what we managed to do. So here we have a Unity application on the left, and there's a box that's moving. And what happens is that the actual environment is stored to a GLTF file, a GLTF binary file, should I say, and it is sent to the server, and the server then passes this onto a Python file, which is seen on a Python application, which is seen on the right. And what you kind of see is the cubes are being mimicked between the two environments. So we were translating the cube, and we were actually adding new cubes into the environment, and the other application replicated the scene, very faithfully. Just So one of the strategies we used is for the translation messages, we could encode each node within the GLTF scene description with a UUID, and then in this packet we could update the position or the scale, the rotation of this object within the environment and track it. And on the client side, we could just use a hash map to represent the scene graph, and we could use the UUID to get elements from the hash map, 3D elements, should I say, of 3D objects from this hash map. And it becomes a very highly efficient method of communicating if we're just using state. And slightly over time, but what we managed to do is develop a proof of concept distributed system that uses GLTF as a neutral scene graph, much like in scene graph as bus. We were able to replicate game objects and move them around and improve upon our packet design, which you can read in the paper. And it's a good starting point, but I think there's a lot more work to do. And I think this project I think there's a lot of potential. I think Anthony as well. I think we think that there's a lot of potential for something like this in the future. And yeah, that's it.